In this lecture, we're going to cover section 3.2, valid argument forms, part 2. So we're going to continue where we left off in section 3.1, and we're going to add a couple of more valid argument forms. So the first one in this section is called the disjunctive syllogism. We're going to abbreviate it DS. So this is the third valid argument form that we're going to look at. It's called like I said, disjunctive syllogism, and it's abbreviated as DS. So symbolically, this tautology can be represented as either P or Q and not P. So if P or Q and not P, then we can conclude Q. Or we have if P or Q and not Q, then P. So if we look at it from a truth table perspective, so if we take our premises, so P or Q and not P implies Q, right? My conclusion is Q. The truth values are always true, regardless of, what P and Q are. So we have a tautology. So why don't we just practice like we did in the previous section? Let's just identify if the following arguments are an illustration of the disjunctive syllogism. So remember, we could keep it right here. So just to refer to, so we have P or Q and not P, then we can conclude Q. Or if we have P or Q and not Q, then we can conclude P. So let's look at the first argument. So R or not S and S. So does that follow that pattern, right? Well, we have a disjunction, right? Remember, disjunction is the or statement. And we have S, which is a negation of the right-hand side of this or statement, right? So if that's the case, then we could conclude the left-hand side, which is R. So yes, this is an illustration of the disjunctive syllogism. Look at the second one. Right off the bat, this is not, because we need to have a disjunction, an or. This is a conditional statement, right? So it doesn't even follow that pattern. Next, we have P or Q and Q. And then our conclusion is P. But this doesn't follow the same pattern, right? Because if I have P or Q, my next statement, my simple statement, has to be a negation of either the left or the right-hand side, and we don't have that. And we'll look at one more. So we have a disjunction. The left-hand side is P implies R. The right-hand side is Q. So for my other statement, my other premise in the argument, we do have the negation of the left-hand side of this disjunction, right? So the conclusion would be the right-hand side, which is Q, right? If this is an illustration of the disjunctive syllogism, which it is. So it follows that pattern. So let's look at the next example. This time it's given in words. Let's kind of go back to practicing an argument that's given in words. First, let's look at it symbolically. Let's express it symbolically. And then since we're told that it's valid, let's construct a formal proof. So if it is Halloween, then I will buy candy. So if H, then B, right? So that's going to be my first premise. Then it says it is Halloween or Christmas. So I have a disjunction, right? So we have H or C. Then we have the premise, I will not buy candy. So not B. Therefore, so that's going to be my conclusion, right? It is Christmas. So therefore C. So let's construct a proof, a formal proof for this argument. So we're going to set up our table, right? So we have to have a statement and then a reason. And let's keep in mind the previous argument forms that we had, right? In section 3.1, we had modus ponens and modus tollens. So don't forget about those now, in addition to the disjunctive syllogism. So either if we have a disjunction P or Q, if we, have the premise not P, then we could conclude Q, the right-hand side, or if we have P or Q, and we negate the right-hand side, right? We join those two statements, then we can conclude P. And you know what we'll do also? Why don't we do this? Let's put modus ponens, right? So let's have that here. So P implies Q, then P, and then we could conclude Q, and then modus tollens, don't forget, we have P implies Q and not Q, which is gonna conclude not P. And then we have the disjunctive syllogism, right? So if I have P or Q, and then if we have not P, we can conclude Q. Or if I have P or Q and not Q, then we can conclude P. So like we were doing in the previous section, we have three premises here, right? We're assuming all of them are true. I like to always start with a simple statement. So I'm going to start with not B. And the reason it's true is because it's a premise. And I'm going to check it off because we already used it. Now I'm looking to use that with another premise to see if we could use one of these valid argument forms, right? So H implies B, which is the first premise, has a B in it, and we're working with not B. So I'm thinking, okay, maybe we could do something with that conditional statement. So I'm going to state H implies B, and it's true because it's a premise. So I have a conditional, the right-hand side is B, and if I, join that with not B, the negation of the right-hand side, then I'm going to get not H, right? Modus tollens. That's this one. On statements 1 and 2. So we were able to conclude that not H is true because of modus tollens. Now I only have one more premise, which I'm going to state N4, H or C. It's true because it's a premise. And I have a disjunction. So you see 3 and 4, I could, if I have not H and H or C, right? So we're negating the left-hand side of this disjunction, not H. Then we can conclude C by the disjunctive syllogism, right? On 3 and 4. So that's this one right here that I just circled. And C is my conclusion. So we just showed that it's true. And that concludes my formal proof. So let's keep practicing. And you know what I would do? Write down so far these 4 valid argument forms. Modus ponens, modus tollens, then the 2 forms of the disjunctive syllogism. This way you have them in front of you when we're working on these proofs. So let's look at the next example. So I gave you a couple of arguments. First, we want to see if they're valid. If they're valid, we'll construct a formal proof. If they're not, we'll show a counterexample. So let's look at this first argument. Let's assume all my premises are true. So if not P is true, then P is false. And I have a disjunction here, and the only way a disjunction can be true, if one of the sides is already false, the other side has to be true. So not Q is going to be true, which then makes Q false. And we have a disjunction, but we need it to be true, so not R has to be true. And not R is my conclusion, which would also be true, right? So we just showed that this argument is valid, but now let's make a formal proof. So we need statements and reasons. All right, so let's clean this up. Again, I like to start with just a simple statement. So let's see where we could go with not P, right? So it's a premise. It's true because it's a premise. Now look, we only have two other premises, and I see the third one contains P. So I'm thinking, and it's a disjunction, right? So maybe the disjunctive syllogism. So for 2, I'm going to state P or not Q. True by being a premises. And I'm going to use the argument form, right, for the disjunctive syllogism, because I have an or statement, P or not Q, and then we have and not P, right? So my conclusion's going to be not Q. So DS, disjunctive syllogism on 1 and 2. So far we used the first two premises. I'm sorry, the second and the third premise. The only one that we have left is Q or not R, right? So it's a premise. And we're trying to show not R is true, right? The conclusion. And look, I have another or statement, a disjunction. The left-hand side is Q, and the premise before it is not Q, right? So if I put those two together, I have the disjunctive syllogism again that I could apply, right? So my conclusion is going to be not R based on the disjunctive syllogism for statements 3 and 4. And we just showed that the argument's valid. Let's look at one more example. Let's see if this argument's valid or invalid. So let's assume the premises are true. So if C is true, then not C is false, which then makes B true, right? Because we want that statement to be true. So B is true. Now, not A could be either true or false, because true to a true is true, but then false to a true is also true. So not A could be true or false. If not A is true, then my conclusion is true. But if not A is false, then my conclusion is false, and we're showing the argument's invalid, right? So this is a counterexample. So we have A, B, and C. B is true, right? And C is true. Now, when would we get a false conclusion? When not A is false, which then makes A true, right? So this would be my counterexample. When A, B, and C are all true. My premises would be true, but I would have a false conclusion. So there's one more valid argument form in this section. It still involves a disjunction. And this one's called the disjunctive addition, and we're going to abbreviate it DA. So symbolically, this tautology can be represented as if P, then P or Z. So in argument form, we have the premise P, and then we have the conclusion P or Z, which makes sense, right? Because think about it. If P is true, then no matter what I join P with, whether Z is true or false, I'm still going to have a true statement, because a true or anything is still going to be true. So let's, now keep this in the back of our head, right? So we have the disjunctive addition. We have the disjunctive syllogism, which let me write them down over here just so we could use them if needed. So if we have P or Q and not P, we could conclude Q, or if I have P or Q and not Q, we could conclude P. So first, let's test this argument here to see if it's valid or invalid. So we have two premises. We're going to assume that they're true. So if G is true, then G is true over here, right? And true or anything is going to be true. And we have a conditional. So true implies W has to be true in order for that statement to be true. And then my conclusion is true. So this is valid. So let's set up a formal proof. So we need our statements and our reasons. Not much going on here, right? This is not a large argument here. So I'm going to start with this single statement, right? G, it's true because it's a premise. Now, this, even though there's not, a lot going on here, it's still, we have to look at this from all different perspectives. You're not always going to be able to put together two premises right away to make a conclusion. So what I mean by that, you see how my first statement is G, but then the only other premise that I have is G or H implies W. But those two premises together, right, those don't look like any of these valid argument forms that we've been using. But let's kind of piece together, like, look what I can do. I can form G or H, right? Because if G is true, right, that's a premise, then G or anything, but I want to use H because that's part of my premise, right? It's also going to be true. And that's because of the disjunctive addition on reason one, right? So I was able to take G and join it with H and still going to be true because G is true. That's how this disjunctive addition works. So if I have a simple statement, I could join it, right? Create a disjunction with another simple statement or variable and still going to be true. Now I have G or H, and that happens to be the left-hand side of this conditional statement. So now I'm going to list this conditional statement, G or H implies W, and it's true because it's a premise. And look, if I put 2 and 3 together, you see how G or H is the left-hand side of the conditional in 3. And that's going to be modus ponens, right? Remember modus ponens. If we have P implies Q and P, my conclusion is Q. So my conclusion in this case is going to be W. And W happens to be, right, the conclusion of the entire argument. So this is modus ponens on statements 2 and 3. And then that wraps up the formal proof. So these take practice, they really do. Once you do enough of them, you kind of really get the hang of it and you know what to look for when you're kind of going through these arguments. So let's do another one. So let's look at the next one. So first, let's determine if this argument's valid or not. And then if it's valid, we'll construct a formal proof. So let's assume that our premises are true. So if P is true, right, then not P is going to be false, which would make R true in order for that disjunction to be true. So then not R is false, and it's the right-hand side of a conditional, so the left-hand side has to be false in order for that conditional to be true. So S is false. So then not S is going to be true, and true or anything, right? Q is going to be true. So the left-hand side of this conditional is true no matter what, which forces Z to be true in order for this conditional statement to be true, and Z is our conclusion. So that's true. So we just showed that this argument's valid. So now let's construct a formal proof. So we have our statements and our reasons. So let's clean this up. So I like to start with just, a simple statement that's a premise. So let's start with P. It's true because it's a premise. Now I see I have another premise that contains not P. It's a disjunction. So I'm thinking I could use one of my disjunction or just disjunctive valid argument forms, right? Whether it's the syllogism or the addition. So let's see. So let's write down the third premise. So we're going to have R or not P. So it's a premise. And I see that that's the disjunctive syllogism, right? Because I have a disjunction, R or not P, and my other premise is P, right? Which is the negation of not P. So then from there, we can conclude that R is true. So disjunctive syllogism on 1 and 2. Now I see my second premise, S implies not R, and I have an R in the previous statement, right? So maybe we could do something with that. And I have a conditional, right? S implies not R. So I'm thinking, okay, maybe modus ponens, modus tollens, right? Because that's a conditional statement. And this looks like modus tollens, right? Because the right-hand side of the conditional, right? When I join it with the other statement, that other statement is the negation of the right-hand side. So then that conclusion is going to be the negation of the left-hand side. So not S. So that was modus tollens for statements 3 and 4. So again, if we want to list these, we have modus ponens, modus tollens, so I only have one more premise, right? But that entire premise is not going to be helpful right now if I list it, right? Because it's a conditional. The right-hand side is Z. I don't have a not Z or anything like that as any other statement. And the left-hand side is not S or Q. I don't have that either. But I'm thinking, well, I have a not S in 5, right? So what if I took not S and I joined it with Q? It's still going to be true, right? Because not S we already know is true. And wait, I just realized here, let's back up a minute. 4 here was a premise. I forgot to write that down. So 4 is a premise, right? S implies not R. And then not S we got from modus tollens on 3 and 4. So now I could take my statement in 5, not S, and join it with Q, and it's still going to be true, right? That's my disjunctive addition. So I'm joining or adding, right, Q to not S using my or statement, and it's still going to be a true statement. So disjunctive addition, DA, on statement 5. Now that's the left-hand side of that fourth premise, right? Not S or Q. So I'm thinking, okay, let me list now that fourth premise. So we have not S or Q implies Z. So it's a premise. And look, 6 is the left-hand side of the conditional in number 7. And that is the pattern for modus ponens, right? So we're going to be left with, right, the conclusion is going to be Z. And that is the conclusion to my argument, right? So that was modus ponens on statements 6 and 7. And then that concludes this formal proof, right? Because we listed all our premises and then we were able to show the conclusion is true. So let's look at one more example. I have one more on this worksheet. So let's look at this argument, test if it's valid or invalid, and then we'll take it from there. So let's assume the premises are true. So if P is true, then P up here is true. Q can't be false, it has to be true. So then Q over here is true, which is going to make R or S true. It can't be false, right? Or else my premise would be false. But R or S could be true a couple different ways, right? We could have true or true. So if S was true, it wouldn't really matter what R is, right? R or S, if S is true, is still going to be true, which then would make the conclusion true. But we have to consider, well, what other ways can this or statement be true, right? What if S was false? Then my conclusion would be false. And then what would R have to be? It would have to be true because true or false is true, right? Making the right-hand side of this conditional statement true. But then the argument's invalid, right? So there is that possibility that if S were false, right, then my premises are true, but my conclusion's false, therefore making this argument invalid. So my counter example would be, so we have P, Q, R, and S. So P we said is true. Q is true. Now, S would have to be false, right, for the conclusion to be false. And we said if that was the case, R had to be true. So my counter example would be when P, Q, and R are true, and S would be false. So this wraps up section 3.2. In the next section, we'll look at more valid argument forms. But in the meantime, I want you to practice with the homework assignment for section 3.2 because it'll help you really get familiar with modus ponens, tollens, and then the two disjunctive argument forms, the syllogism and the addition.